Are we good? Can you hear me? Am I coming through? All right. Cool. Welcome, everyone. Thank you for joining. My name is Eddie. I'm an engineer at Intel, and I'll be your host. We're very excited to be here supporting all of you, the developers, engineers, architects, who are building pretty awesome things. So, AI applications. No longer just a single model running in a single place anymore. Today, developers are building agentic systems that basically distribute across cloud, edge, and client. So in this session today, what we want to do is we want to walk you through what this looks like using 3 different demos. First, we'll start on the client side. So think lightweight agents running locally for fast real-time interaction. Next, we'll move to the edge, and we're talking distributed systems, so multiple systems coming together to handle more context, more complexity at the edge. And then finally, we'll move to the cloud, talking about multiple agent orchestration happen at enterprise scale on Azure. So first off, I'd like to introduce our first presenter, Jayneel, who's going to talk us through the AI client demo. Jayneel?
Thank you. Hello, right on. All right, we have that here. Awesome. Quick show of hands. How many of us have maxed out our monthly AI budget? Awesome. I have too, and I've got the side eye from my management as well. So, today I want to show you something that might tell us that that ceiling does not need to exist. A lot of times when we are generating tokens, every token has a round trip, it has latency, it is a cost item associated with it, and we cannot build and deliver a lot of features because the math just doesn't math, it doesn't make sense. So today, I want to showcase Ion 1.0 Instant that was released just yesterday. Satya talked about it at the keynote as well, on Intel Panther Lake NPU, the Core Ultra Series 3. All of this runs on the device itself. So before we get started, on the left side, I have the chat interface. Nothing special, something we can whip up right now in the next 30 minutes. On the right side, I have the systems panel, where I've showed up the NPU, the neural activity, the CPU, the memory, and all the good stuff. So I'm going to start talking to it, and we'll see everything here. I would love if you pay attention to the right side more than the left side, because that's where the real story is. I'm just prompting right now. What is the color of the sky? The color of the sky is blue. If you see right here on the systems panel, you might see NPU activity happening, a very small blip. This NPU is the Intel Panther Lake, which is 50 TOPS of AI throughput. And it runs, it's not even taking 20% of that. Now, let's give it a bigger prompt. Why is the color of the sky blue? Look at how fast that was. This is on your device. And there's NPU throughput right there. Look at the memory. It did not increase by a lot. So when you think of it, your features, your app has features. Your users have a lot of things going on their systems. This just coexists. If you look at the CPU as well, there was a small blip there, nothing going on there. So there's no thermal throttles, no power falling off the cliff, no fans as well. So that's the best part. The best thing that I feel as an engineer on the Intel Panther Lake that just came out in January is it allows for very aggressive quantization strategies, so you can really compact your models, and which allows us not to have to choose between getting a model that is faster or smaller. You get both. You get a faster and a smarter model, and you get both. This would run in a hospital, on an airplane, anywhere where the data does not get out of the network. And it runs for free for the 10,000th time. Something I'd also want to point out is there is, quick thing. I want to show you. I want to do one more prompt. What happens if the sky is polluted? Or let's say, what happens to the color of the sky? And I made a spelling error there, but it's still pretty good. So we see that right here as well, right? All right. Again, the best thing about this, again, is I did not write any NPU code for this. This is all using OS-level APIs. I got the AI model. I worked with it on the NPU. I just put it on the NPU and ran with it. It used OS-level APIs, OpenVINO at the bottom, WinML on top, and that's all. Scheduling is the platform's job, not ours. We build features, and that's all we do, right? It just takes care of it. Microsoft gives you the model and API surface, and Intel makes sure that when you have the app, it runs on device, on premise, and it's always available when you're not connected to the network. And the code always runs clean, fast, and cool, and on hardware that your users already own. So that's the Ion 1.0 instant on Intel Panther Lake NPU. And I want to show you a quick thing. It's a quick call out. We have a really cool demo right here. It's reasoning on Intel NPU at the booth. It's a game that I like to play. You put in 2 words, and you can get a relation between the two. So it's really good at reasoning. It reasons pretty well on the NPU that we have. So look forward to seeing you at the booth. Thank you.
All right. Thanks, Jayneel. Okay, next up, I'd like to bring up Colin to the stage. He's going to showcase this pooling of resources on these stacks.
Excellent. Thank you. All right. Thanks for joining us today. What I'm actually showing you, so as we said, edge use case, this is client, and it's AI on client. So what I brought for you guys today is I've got 3 of the new ASUS NUC Pros. This is the NUC Pro 16, and they're running our latest Intel Core Ultra Series 3 processors. Specifically, these are running X7s. So when you're shopping for this Core Ultra Series 3, that X means that it has our big built-in graphics. So benefiting from that, obviously, is gaming, because on one of these, I mean, this is a LAN party stack if you were gaming on it, but the way I'm using it is for AI. And what I brought to show you guys today is kind of how flexible the platform is when it comes to AI. So each one of these, as I said, has our big Arc B390 graphics built into the chip, and they have 64 gig of RAM. What you can do today, though, built into our graphics driver, so this is the free driver for our graphics that you can download from Intel.com, is you'll see the second thing down there that says Shared GPU NPU Override. So with the big graphics, we are enforcing our OEMs to put really, really fast LP DDR5X memory in there. So 9200 or faster is what we're really shooting for. So it's really fast memory that's in there. And so what we've enabled for AI is this little slider that you see, and right now it's set to 81. I've got 64 gig of RAM on one of these. But by adjusting this, I can set up to 93% of that RAM as video RAM. So if I change this, I do have to reboot, but as you see here in Task Manager, I have 51.3 gig of VRAM, which means I can take a single one of these systems and I can work with the latest Qiin 3.6 28B models really, really well. I've taken it another step further here, because having these 3 systems together and the performance of the graphics and the processor that we have, I've used 𝗲𝗲𝗀𝗶𝗶 and the RPC functionality that is in 𝗲𝗲𝗀𝗶𝗶, and I've connected the 3 via IP, and by doing that, I pool the resources together. So all of a sudden, this little stack of NUCs has 150 gig of VRAM that you can load a really large model into. So what I have here to show you guys today is just, to show you, I've got Copilot CLI. I could have a model, an agent running on here, but if you come by our booth, you can see I've got an agent running on a stack there. What I did for you guys in here, though, is I want to show it completely offline. So the network I have on these is actually, and you're welcome to show you, but I have little point-to-point Thunderbolt cables. So I'm using Thunderbolt 4 to network the three together, and those are 20 gigabit links between each system. And then, using Llama, I'm able to load really up to about 180 billion parameter model onto these things. What I'm showing you guys today, and you can kind of see it down here, my head's not in the way, is I've got the QNext ADB A3B model on there. And that is running at about 16 to 18 tokens per second off of these little systems. So just to build on what Jayneel was saying, this gives us free tokens. This is a really smart local model, and the total cost of that stack is less than $7,000. So when you compare this to some of the other solutions out there, you might get a little more speed, but this is really, really flexible. Even a single system is really potent. So if you were to buy a set of these, you know, it's almost cheap enough to put one on every developer's desk and let them work with the larger models before they move on to more enterprise, you know, capable solutions. But even if you had, say, a team of 10 people, you could, you know, load a 28, 35 billion parameter model on each one, and then load balance them and support a whole team of people. So it's really, really flexible. It's low cost. And on top of it, these guys draw maybe 100 watts apiece. So we're very low power. It stays cool. What I'm showing you here, there's no network backbone stuff to pay for. It's just Thunderbolt cables, USB 4 cables, really. And what it allows you to do, as you see here, I've got Copilot, the Copilot CLI, which is the agent that's built into Visual Studio. A lot of people aren't aware, but as you see here, you can point it to local models. To do that, all you have to do is set a few environment variables, which you can see here. So here, I set the model, I tell it the endpoint IP address that I'm using, give it the API key, and then from then on out, in Visual Studio, I'm using an 80 billion parameter model to check my code and to work with. And again, free tokens. So one of the biggest complaints we hear from a lot of people is my company gives me 5,000 tokens a month, and I use those in an hour. This is your answer. This is a much more cost-effective way of deploying a large model for a small team to use it. And you know, just to kind of show you what I also have going on here, because I do have the Copilot CLI up, is I'm going to show you guys a quick process. And one of the things I enabled, which you see in the Copilot CLI, was announced yesterday. So if you didn't get a chance to hear about the new MXC, Microsoft MXC, which is their execution containers for agents, you can start experimenting with those today. And to do that, you can set up Copilot CLI. It could use a local model, it could use a cloud model, but what you're trying to do is you're really encapsulating the code and not letting it run off and you know, do things you don't want it to. So just to show you some of the configuration, you can configure it to allow access to MCP servers. You can give it certain file systems you can access, or you can even set the network in and out. And you may start thinking there are other tools that can do this, but the beauty of MXC is it's part of the Microsoft platform, which means these settings can be set through policy. So your administrators are happy, developers may not be as happy, but it will keep them reined in and make sure everything is nice and safe as they're running it. And to just show a quick sample, because I am sandboxed here, I'm going to go ahead and ask this thing to run a script. And I got an easy script that I like to show if I can spell right. You know, spelling doesn't matter with AI, so, but I want to say run a script that pauses 5 seconds. I'm a fast typer. And I want you guys to keep an eye out over here under the background processes, because when this runs, and you'll see, first of all, it's working with a model. It's talking to the model right now. what's a script? How do I build a script? Let me build a script. I need to use PowerShell to run the script. And it's a little slower than I'm used to this morning. This is demo demons coming at me, but because it's containerized, you'll actually see a little execution container pop up on the left side over there that's an executable, and it'll pop up and disappear really quick if the script finishes. Looking at my time. Demos. All right, well, just to make sure and let you guys see the model is running, I'm gonna go ahead and cancel this a second, and I'll show you the web interface for the model. You know, this was working 2 minutes ago. So we'll go ahead and just to show you the speed of the model, I'm going to say, why is the sky blue? And at least here you can see the token processing speeds of the model itself running across these three. There's a little bit of hiccup between the CLI and it. It's like the first time it runs when the model's coming up, it takes it a little bit longer because I just brought it up. But once it's up and running, you get a pretty good, as you can see, pretty decent token speed. I'm seeing right now around 12 with this model, but it boosts between 12 and about 16. So again, cost-effective, free tokens. It's really meant to be able to experiment and develop with. So hopefully this is something new to you guys, something you've learned a little bit, and it starts you thinking of new ways of using small edge client PCs like this, not just individually, but distributed. So thank you.
Thank you, Colin. Very compelling demo, showcasing the power of this pooled resources. Okay, so next up, I'd like to invite Imran to the stage. He's going to talk to us about our final demo, data center and cloud.
Thanks, Eddie. Good morning, everyone. Hope you had a good ride over to the convention center today. On your way to the convention center, you would have noticed a lot of billboards talking about Agentic AI. And Agentic AI has really transformed how we interact with LLMs, far more beyond that what chat used to be, right? So with chat, you just type a bunch of queries, you just type a bunch of text, and what you would see is that you would see the LLM response to your chat questions, even right now you see that the tools that you interact with, the online tools that you interact with, they kind of moved and execute the two commands on a private VM and a sandbox and whatnot and get the tools out. And all the thing that ties these together in common is the context sizes. So context sizes have gone way much beyond the traditional methodologies, the traditional sizes that you've seen in chat, say like 1,000 tokens, 2,000 tokens. The common standard where people tend to start when it comes to agentic systems is at least a minimum of 10,000 tokens, right? And so token sizes have gone larger, and running local AI with accelerators, with GPUs, the memory on the GPUs have become a slightly bit of a bottleneck. But what if you have a better way to do or reuse the private VMs that you already have in your VPCs? And that's what we'll be looking in this demo. So we'll be hosting our own local LLM here. So the LLM that will be hosting on the system, which has 96 cores of virtual CPUs, hosted on Azure VM, and it's going to be having about 200 GB of RAM available in it. So we'll be loading Qwen 3.6, 35 billion parameter model with 3 billion active parameters. And one of the good shifts that we see with open source, that with mixture of experts model, not all the parameters gets activated when the model is executed, right? So only a fraction of those active parameters gets activated. And that's kind of advantageous for running them on Xeon 6 CPUs, because Xeon 6 CPUs has AMX built into it, which speeds up matrix multiplication, and more than 80% of the execution operations in transformer-based models, they are predominantly MATML, and that also directly transfers into how the prefill time kinds of impacts that time taken for first token impacts your solutions, right? So now that the model is up and running on the left side, you see that the model is serving right now, and I also have another instance where you can see that I've deployed OpenFlow, the harness on a Kubernetes-based system, right? So you just have one OpenFlow system just up and running. We can check the status of it by issuing OC status. And it is up and running, and it is mapped to the model that we just have it on that we just loaded on the left. And that's something that you see over here. The Qwen 3.6, 35 billion with the context size of 200,000, right? So scenarios where you want to have, where you do have spare CPU cycles and you do want to have private agentic AI, this setup is something that you could traditionally use. Now let's go ahead and ask OpenFlow to interact and list a set of issues that's listed in a private GitHub repository, right? So typically what happens is that when you give this command, OpenFlow is going to parse this command and send it to the LLM inference token to understand what tools it needs to call, right? So we've set up the GitHub command line interface inside the OpenFlow instance so that it can absorb the information that's been passed from the LLM and run the commands actually. So what you see happening is two steps process. One, LLM instructing what commands to execute, and by the time the steps have been executed by the OpenFlow, it sends back the information to the SG Lang LLM serving engine, which kinds of summarizes the output based on the input that we just gave. So that's something that you're going to be looking at it over here. And what you can see is that the tokens being printed is roughly around 15 to 16 tokens per second. You can kind of increase this throughput also by a couple of ways. One is torch compile. When you compile it, it's going to be much more faster. You could get around 21 tokens with these 96 cores. You can also do a draft model with speculative decoding that is going to be coming up soon with SG Lang. We already have a draft model, speculative decoding model available in other inference engines like VLLM. So all the popular inference frameworks like VLLM, SG Lang, we supported that. So what you see here is that the output from OpenFlow, it has listed a bunch of issues and PRs that's available in the ticket that we just talked about. So now let's ask OpenFlow to go ahead and create a list of the riskiest file for a specific issue, so that it kinds of goes through the issue, so runs the GitHub command line to extract that information, passes it to OpenFlow, the same process again, and kinds of gives us a summary that what you want, right? So the first step is completed, meaning the instructions has been translated into whatever execution commands that OpenFlow has to execute. Now it's just running the summarization or kind of generating the response to it. And you can see that only one file was changed in that specific issue that we're talking about, and probably because of that as the registered case file. Now the advantage of keeping the OpenFlow instance, just in this case harness, which can be easily replaced by any other harnesses like say 𝗦𝗽𝗲 or Hermes or anything for that matter, is that you could also do auto scaling. So we're going to look at how auto scaling is going to be happening here. So for starters, we'll be looking how many instances of the mini pods are running right now, and this is something that you get, right? So right now we just have like 2 replicas running at the same point in time, and then when you go and automatically increase the load on the system, you'll see that as and when the load gets increased, as and when the CPU utilization gets increased, the replica will automatically increase. And the advantage of having this way is that you could spin up multi-agents, or you could also kind of scale the instances into multiple set of scenarios and give it to multiple personas, say something like a PM, like a reviewer and whatnot, who can use the same instance in a single given box to do the end-to-end workflow that you need. You could also just push it in kind of a nightly job of sorts for the agents to communicate with each other and kind of complete the entire coding for a specific PR or specific issue that's been listed. So that's something that you could do with a single VM hosted on Xeon, and it's going to be not heavy on the pocket as well. So that's all the demo that we have for today. Thanks.
All right. Thank you, Imran. Okay, so those are our 3 demos for today. I think we have some time for any questions. So do we have any questions for our presenters today? How expensive are these boxes?
Individually, they're about $2,500, but that's the highest spec you can possibly put in them. Yeah, yeah. The whole stack should be, well, really around 2,300. The whole stack's about 7,000. Yeah. When they're stacked up.
So how does the scheduling of the model or the workload management happen on the stack of devices?
Right now, it's using a single llama CPP endpoint. So there's different ways you could do this. Right now, I'm sharding the model into 3 different and pushing it out. When I first load the model, the biggest usage of the network is when you first do that. And the faster your network, the faster it comes together. And then once it's together, I just have RPC servers on each one. And so Llama handles calling out where it needs it from which machine on its own. Yeah, and so you just use Llama to set up your OpenAI endpoint, and then you can point all the agents or anything you need to it. Yeah.
So Llama takes care of breaking it down, the model into
Yep.
different layers.
Yep. Yep. It's all very off the shelf. What I've done here is I'm actually compiling. I know you say compile and it sounds scary, but I compile Llama CPP, which is like 2 or 3 lines of terminal, really. But you have to enable, there's a dash RPC. And then I'm using the Vulkan backend here because I am directly using the graphics. And so for this use case, that works really well. And so yeah, that's kind of how it's put together.
So one last question. Could we support similar capability to OpenVINO, whatever Llama does? Could we do
It's coming. It's coming. OpenVINO is real. So if I was doing individual machines, OpenVINO is going to beat most of what I'm doing. It's because I've got it using the RPC servers. OpenVINO needs a little bit of work because it kind of gets confused about the memory. But like I said, if it's a single machine running it, it's going to be a lot faster than just the Vulkan. Yeah.
Do we have any further questions?
Come by the booth if they don't.
All right. Well, that's our time for today. Thank you, folks. Any more questions, swing by our booth. Appreciate the attendance. Enjoy the rest of the conference. Thank you.